Part 4, Relationship of Exponential and Logarithmic Functions. The function y equals log base b of x and y equals b to the x are inverses. So the logarithmic function and the exponential functions are inverses. Show that g of x equals log base 2 of x and f of x equals 2 to the x are inverses. Remember that an inverse means that f of g of x equals x and g of f of x equals x. If those two things are true, then f and g are inverses. So f of g of x is f of log base 2 of x, which is 2 to the log base 2 of x. Now log base 2 of x means the power of 2 that gives us x. So we have 2 to the power of 2 that gives us x, which would be x. And if I do g of f of x, that is g of 2 to the x. So log base 2 of 2 to the x. That means 2 to what power is 2 to the x? Well, the power is x. So these two functions are inverses. This is the graph of log base 2 of x, and this is the graph of 2 to the x. And we can see they are symmetric about that line y equals x, so they are inverse functions. Looking at properties of the graphs of logarithmic and exponential functions, we see a lot of similarities. They are inverse functions, which means the domain and range are switched. So for an exponential function, the domain was all real numbers, which means the range of a logarithmic function is all real numbers. Because we switched the x and y, because they're inverses, so the domain of a logarithmic function is 0 to infinity, which is the range of the exponential function. The asymptotes are also similar, except for when we switch the x's and y's to make them inverses, we also switch the x and y on the asymptotes. The intercept for the exponential function is 0, 1. Well, for the logarithmic function, it's 1, 0. And if we have some random point CD on the graph of y equals b to the x, that means that log base b of x has on the graph the point DC. And again, we can see all of that on these two graphs. So exponential and logarithmic functions are inverse functions.